Hello students, welcome to my channel Positron. Dear students, in many videos I have discussed with you all that why the name of my channel is Positron. Actually, you know the fundamental part is about the 5 states of the matter. You know 5 states are what? Solid, liquid, gas, Bose-Einstein condensation, B condensation and plasma. Whatever be the states, they all are made of molecules, and molecules are further broken into atoms, and atoms are further broken into electron, proton and neutron. These electron, proton, neutron are said to be the fundamental particles. Fundamental particles are what? Those which cannot be broken further are said to be the fundamental particles. Dear students, every particle has its own antiparticle. Like electron has proton has an antiparticle called antiproton. Neutron has an anti-neutron, and the electron has the antiparticle that is called positron. Positron has a similar mass of electron, but the charge is opposite. Electron is a negatively charged particle, whereas positron is a positively charged particle. So fundamental particles are those which cannot be broken further. Dear students, you know about electron, proton, neutron. Right now, till today, more than 65 particles have been discovered so far, which are said to be the fundamental particles. Few I can name: electron, proton, neutron. Obviously, you all know about. And then, just I told, antiproton, positron, neutrino, antineutrino, meson, pi meson, negative meson. A lot more than 64 particles have been discovered, 65 particles have been discovered so far. Most of these particles that I named are the part of cosmic radiations. In the cosmic radiation, these particles are mesons are formed. Okay. So today's topic is a capacitor part 3. On the capacitor, already I have made the 3 videos. This is the capacitor part 4, right? Today's topic is a combination of capacitor. Combination of capacitor. Dear students, you already know, you have studied the combination of resistances. Today we are going to study, in the electricity, in electric current topic, we will again study the combination of resistances, right? And combination of resistances and capacitance together too. Today's topic is a combination of capacitors. Dear students, already in my first video when I was discussing about that what capacitor is and how does it work, I told you the 3 devices you have, the 2 very important devices you have to, you are supposed to know. Capacitor is a device which stores the charge. Right? Capacitor, a device which stores the charge, or you can say that capacitor is a device which stores the energy in electrical form, which stores the electrical energy, right? And inductor is a device which stores the magnetic energy. They stored, yet I have not made the videos on how to calculate the energy of capacitor. Next video undoubtedly will be based on that, or even in today I'll do that. So the stored energy in the capacitor is half CV square, whereas the stored energy in the inductor is half Li square. There is a combination of capacitors. Today's topic is there are 2 types of combination. One is a series combination and another is a parallel combination. Series combination and another is a parallel combination. In the series combination, this is how, right? Let three capacitors are connected in this way. This is positive plate, this is negative plate, this is positive plate, this is negative plate, this is positive plate, this is negative plate. And here these are connected with a battery having the potential V, right? The three capacitors are connected in this way. Their capacitances are C1, C2, C3, and ultimately this combination is connected with the battery having the potential V. Dear students, you know, first, how will you judge that this combination is a series combination? Look here, this negative plate is connected with the positive of other capacitor. Again, this negative plate is connected with the positive of next, and negative is in this way. Or you can say that in the series combination, charge remains same on each capacitor, whereas potential is divided. Now, I am going to prove my words, what I have said, that in the series combination, charge remains same, and whereas potential is divided. Look here. This is the battery having the potential V. This combination of three capacitors, might be infinite capacitors, have been connected with the battery. From the positive plate, let charge Q is issued from the battery, it will come, so then it will come here. This will become positive, this will become negative, this will become positive. Now question is that if here is a negative charge, then how will it be positive? People do ask that if there is a negative charge, then how will it be positive? Look here, dear student, positive charge has been issued from here. It comes to positive this plate, which becomes positive. Because of induction, this front plate will become negative. Look here, this one I am making big, like this. So positive charge is given to this one becomes positive. Now, because of induction, this one becomes negative, and opposite side becomes positively charged because of induction, and this positive charge will be transferred to this one, and this way this charge is transferred. Look here, the charge Q is coming to this, again going to this, again going to this, and going to this, and ultimately received by the battery. If whether it is a current or capacitor, no matters. In the case of whether it is a resistance or capacitor, no matter. In the case of resistance, you release the current. In the case of capacitor, charge is issued. Your connection is true. Your way of describing getting the answer is true only when whatever charge is issued from the battery, the same charge should be received. If it is not so, it means something is going wrong with you. Dear student, look here what I am saying, that charge Q has been issued. From the figure it is clear that this receives the charge Q, and the same charge goes to this goes to this, and ultimately it is received by the battery. Look here, what I have said, that in the series combination, charge remains same, whereas potential is divided. How it is? Look here, potential is not a absolute quantity. Absolute quantity is that one which can be defined independently, right? In the physics, those quantities which can be defined independently are said to be absolute quantity. Potential is not an absolute quantity. It cannot be defined independently. It must be defined with respect to a point. And that is why we talk about the potential difference, not about the potential. Now look here. This potential difference will be divided in these three, right? From where charge is coming? Look here, I have told you in my last video that this is a capacitor is a charge storage device. It cannot produce the charge. You have to provide the charge from elsewhere, from any other source, and it will store the charge. Capacitor is a storing device, not producing the charge. But battery is a factory to produce the charge. It is the battery which produces the charge. This is the difference between the capacitor and potential. Now, the potential of battery is a V. This potential will be divided in this. Look here. This capacitor is connected between these 2 points. This capacitor is connected between these 2 points. This capacitor is connected between these 2 points. So, potential difference is what? Difference of potential between the 2 points. These capacitors are connected between different points. That is why they have the different potential difference. Let it's a potential, the potential difference is V1. This has got the potential V2 and this one has got the potential V3. And from where they are getting the potential? They are getting the potential from the potential factory. I mean, this is the battery which provides the potential to them. So you can say that V becomes V1 plus V2 plus V3, right? Means these capacitors are getting the potential from the battery. Or V is equal to V1. You know, Q is equal to CV. Q is equal to CV, so V is equal to Q upon C. For this one, potential will become Q upon V is equal to Q upon C. Q is a charge upon capacitor and again Q upon C1 plus Q upon C2 for that one, and this has the potential Q upon C3. Now dear students, look here. Very interesting. What is the equivalent capacitance? We have to find out the equivalent capacitance. Equivalent capacitance is what? Equivalent capacitance, how will you define? Equivalent capacitance is one which does the same work what is done by all these 3 capacitors. Equivalent capacitor is what? Equivalent capacitor does the same work what is done by these 3 capacitors altogether. It means you can replace all these 3 capacitors by a single capacitor like this, right? It is the equivalent capacitance, and this one was the battery. It means what these 3 are doing altogether. What these 3 capacitors are doing altogether, they are taking charge Q from this battery and potential V, right? So if you consider the equivalent capacitor, it will take all charge Q from the battery and potential V, because equivalent capacitor does the same work what all these 3 capacitors are doing altogether. So equivalent capacitor is one which can replace all these 3 capacitors. So look here, if these 3 are replaced by equivalent capacitor, then V is equal to this one will get the charge Q, this equivalent will get the charge Q what these 3 we are getting. So Q upon, let it has the equivalent capacitance C. So that is equal to Q upon C1 plus Q upon C2 plus Q upon C3. You can write 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. If there is infinite capacitors, then 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus dot 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 dot. So dear student, in this way, if the number of capacitors are connected in series, then 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Dear student, look here, very important thing I have to discuss with you all. Let 3 capacitors are they are combined in series, and 3 capacitors are 2, 3 and 4. Right? Let the 3 capacitors are having the capacitance 2 microfarad, 3 microfarad and 4 microfarad. They are connected in series. How will you get? How will you know? Let charge Q is received. Charge Q will go to this and charge Q will go to this. So same charge is passing through all the 3 capacitors. So they are connected in series, right? So equivalent capacitance 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. That is 12, 2 6 ja, 4 ja, 3 ja. That is 1 upon C is equal to 13 by 12 or C is equal to 12 by 13. Dear student, it's a very simple question. I know that there is no need to solve this. But what the important is that what is the truth behind this question is, look here, the three capacitors were 2 microfarad, 3 microfarad, 4 microfarad were connected in series, and the resultant, the equivalent capacitor, works out to be C is equal to 12 upon 13 microfarad. This is less than 1. Its value is less than 1. It means if this is less than even 1 microfarad. It means what you can say that? It means if you consider the series combination, then the capacitance of equivalent capacitance will even be less than the smallest one in the combination. These three are having the capacitances 2 microfarad, 3 microfarad and 4 microfarad. They are connected in series, and the resultant, the equivalent capacitance has the equivalent capacitor has the capacitance less than the 1 microfarad, means smaller than the smallest one, right? This is the result, and this result might be very useful while you are analyzing a question, right? During the analysis, it would be very important to know that in the series combination, equivalent capacitance has the capacitance even smaller than the smallest one. Now, let's talk about second one is a parallel combination. Let number of capacitors are like this. Look here, the three capacitors C1, C2, C3 I have connected in this way. Now, what is parallel combination? How will you define? How will you recognize that particular combination is a parallel combination? In the series combination, dear student, in the series combination, charge remains same, whereas potential is divided, because the different capacitors were connected between the different points. That's why potential difference was different. But in the parallel combination, what happens? Charge is divided, potential remains same. How? Look here. This is A, this is B. Between A and B, different capacitors are connected, right? Look here. Between A and B, different capacitors are connected. The capacitances are C1, C2, C3. Let charge Q is issued. Now, all the capacitors, the first plate of capacitors are connected with point A, and second plate of all the capacitors are connected with point B. It means all the three capacitors are connected between A and B. Potential difference is what? Difference of potential between the 2 points. Between A and B, potential difference will be same, and all the three capacitors are connected between A and B. That is why they have the same potential difference. And now let the charge Q is issued from the positive plate of the battery. It will come. So now it is clear that this charge will be divided in the three capacitors Q1, Q2, Q3. In this way, you can say that the charge is divided, whereas potential difference remains same. Now, from the figure, you can say Q given by the battery is divided into three capacitors, Q1 plus Q2 plus Q3. Oh, sorry. Now, dear students, look here. Q is equal, Q1 is what? Q1 is Q is equal to C into V. This is C1 into V, potential is same. And now look here, all the three capacitors are connected between plate and A and B, so they have the same potential. Now look here, what potential will they get? From where the potential will come? Is a battery will provide. The battery is a factory to produce the charge or to potential. It's a battery which will provide the potential to them. So whole potential of battery will be applied between A and B, because between except of A and B, except of between A and B, there is no device. If here had been capacitor, then this potential had been divided between them. Now all the capacitors are connected between A and B, so whole potential of battery will be applied between A and B. So between A and B, the potential difference will be V. So Q is equal to Q1. Q is equal to C into V. So Q1, the charge on this capacitor will be C1 into its potential will be V. Q2 again C to V. Q3 again C3V. And now dear student, let all these three are replaced by an equivalent capacitor. Equivalent capacitor is what? Which does the same job what is done by all these three capacitors together. What all these three capacitors are doing? They are taking the charge Q and potential V. So this Q, these three are replaced by a single capacitor. Let it has the capacitance. So you can say Q is equal to C into, and now if all these three are replaced by single equivalent capacitor, then whole potential will be applied on that. That is C into V is equal C1V. So C is equal to C1 plus C2 plus C3. Dear students, so C is equal to C1 plus C2 plus C3. Dear students, the important thing is that, look here, let the three capacitors are, these three capacitors have the values 1 microfarad, 2 microfarad and 3 microfarad. In this case, equivalent will be 1 plus 2 plus 3, that is 3, 2, 5, 1, 6 microfarad. Now look here, in the series combination what you have seen, you have observed that the equivalent capacitor has the capacitance even smaller than the smallest one in the combination, even smaller than the smallest one in the combination. In the parallel combination, the equivalent capacitor has the capacitance even greater than the biggest one, right? In this combination, 3 microfarad is the maximum one, right? And the equivalent capacitance in parallel combination works out to be 6 microfarad, even it is bigger than the biggest one in the combination. Dear student, I have told you all that in the series combination, charge remains same, potential is divided. In the parallel combination, charge is divided where potential remains same. There are some questions you might solve. Dear student, the next video undoubtedly will be based on the different combinations of the problem based on the parallel series combination, how to get the equivalent capacitance, and especially for those who are the aspirants of NEET and ITJ. I'll try my best, okay, that I can make you all familiar with the physics with the highest level of physics. I think I have tried my best to let you understand. If you think that my videos are useful to you, please and please like, share, subscribe, and must put bell icon so that you might be notified about my next video. Thank you.